Welcome to the Image Crawler Parallel Streams client app portion of Assignment 2. The purpose of this assignment is to deepen your experience using Java's functional programming features and your integration with Java's Parallel Streams and Spring Web MVC. In particular, in this assignment, you'll develop a client-server app that uses several Java Parallel Stream strategies to obtain, transform, and store images. Like earlier assignments, the code you write here has a GUI and runs as an Android client app that can either perform all image processing locally on the client device running Android, or perform all the image processing remotely using microservices that can be deployed on one or more servers and implemented via Spring Web MVC. Please use this GUI along with the unit test discussed below to help evaluate and debug your solution. The following resources may be helpful in completing this assignment. Detailed overviews of the Java Parallel Streams framework are available here, and the book Modern Java in Action is a great resource to learn how to program Java streams. Before you complete the initial submission of Assignment 2, you'll need to do the following. Complete your implementation of Assignment 1B, taking into account my review comments, since it forms the basis for the client app in this assignment. Please come to office hours or post questions on Piazza if you have any remaining questions about your Assignment 1B solution. The Image Crawler app is packaged as a project using Android Studio. The app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 1B, however, you only need to be aware of the following directories. Image Crawler Crawlers, which contains the skeletons you need to fill in, is described below. Image Crawler Source Test, which is a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. And App Source Android Test, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you need to select an emulator that uses an API greater than or equal to 29. I recommend API 30. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Do not change the overall structure of the skeleton. Just fill in the to-do tasks, and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the Image Crawler Crawlers folder. First, the Image Crawler Crawlers Parallel Streams Crawler.java file, where you'll need to complete the to-do tasks in various methods to obtain, transform, and store images both locally and remotely. This class uses Java Parallel Streams to perform an image crawl starting from the root URI. Depending on the parameters used to run the app, images from the HTML pages reachable from the root URI are either downloaded from a remote web server, read from the local file system, transformed locally or remotely, and of course in any case, the results are then transformed and stored in the local file system on the Android device. You'll also need to complete the to-do statement in student.kt to set the type field to include just graduate or undergraduate, depending on which version of the assignment that you're implementing. Your solution should use no loops or if-else statements in this assignment and instead use Java Parallel Stream aggregate operations and functional programming features. Your solution will be considered correct if it passes all the unit and instrumentation tests, is thoroughly commented, and addresses my review comments. The skeleton code for this assignment is available here in my GitHub repository in the client folder. Now that you've set up your GitLab account, you can pull the skeleton code into your repository, read it carefully, and complete the to-do markers. Unit tests in the Image Crawler Source Test folder are provided to increase our confidence that your implementation is working as expected. Please use the Android Studio GUI to run the unit test locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs and not their absence, so don't rely solely on the unit test to detect problems in your code. Assignment 2 is designed to deepen your experience developing apps using Java functional programming features and Java Parallel Streams in conjunction with Spring Web MVC. The skeletons and unit tests are extensive, though you don't need to understand them all to complete your solution. Please start early and ask questions in class, office hours, and on the Piazza discussion forum. So now that we've walked through the specification, let's take a look at the skeletons. The skeletons will be implemented in the parallel stream crawler.java file, which we see here. Much of this file will be the same as what you had for Assignment 1B, with a couple of simple exceptions. In particular, in methods like perform crawl and methods like crawl page, we've updated the unit tests to use map to int instead of using map. And that's because that won't require doing boxing to change from integer to int when we use the various methods that are being processed here. So that's one of the changes you'll have to make. Of course, you were already using map to int in process page, so that can change. That will not change at all. Process image also will be the same as before for assignment 1B, and transform image locally will be the same. Where things diverge, of course, is the new method you have to implement, which is called transform image remotely. And this is the method that will be the proxy to contact the server where the various image transforms are going to be done. So the way you're going to do this is described here. You'll call a helper method called get remote data source, and that will return a proxy to the server. And then you'll go ahead and apply the transforms. And there's a method that you can call on remote data source to apply all the transforms. You have to pass the appropriate parameters. What you'll get back there will be a list of resulting transformed images that come back from the server. You then, of course, will convert that into a stream. And then you'll use an intermediate operation to call create image, which is a helper method also, to convert the received transformed image to a locally cached image. And then you'll go ahead and filter out any null images that may have come back. And then the final thing you do in this method is you return a count of the number of transformed images, which of course is a terminal operation defined in Java parallel streams. This particular implementation does not have to do parallel streams because all the parallelism is being done over on the server side. It just has to take the results that come back there and apply the create image to do the transform using good old map. So that's basically it. There's not a lot of changes here to the existing code from assignment 1B other than changing map to int in the appropriate places in perform crawl and crawl page. But the bulk of the implementation that's new is going to be in transform image remotely. Now that we walked through the specifications and the skeletons for this client app, let's go ahead and run the unit tests. As you can see down here, we come in as usual and we go ahead and run the tests, and that will instantiate the tests. There's roughly 30 or so tests that exercise various features related to sequential streams and the sequential streams crawler and the parallel streams and the parallel streams crawler for the local case. And then in this case, it also goes ahead and exercises the one that runs the tests for the remote implementation, the transform remote implementation. This particular set of unit tests does not actually require the server to be up and running because it uses sophisticated mocking instead. But after you get these tests to work, which as you can see, all the tests pass here is indicated by the results at the bottom, we're then going to show how to actually run the complete end-to-end client server app so you can see what it does when you put it through the paces with the server up and running. So now that we've walked through the specifications, the skeletons, and the unit tests for our client app, let's put all the pieces together and show how everything in our client server application communicates end-to-end. Over here on the left-hand side, we've got Android Studio running, the Android emulator, and on the right-hand side, we've got IntelliJ that's running the Spring Web MVC-based server. And you can see I've already gone ahead and started up the server. So I've got the main application running and the Eureka discovery service running, and then the 3 microservices running, Grayscale, Sepia, and Tint. Over here on the left-hand side, we're going to come in and set some configurations. We've set the transforms to run remotely. We've set the images to be downloaded remotely. We've turned on Grayscale transform, Tint transform, and Sepia transform, and we've chosen the parallel streams implementation. So armed with that, let's go back over here and let's click on the little search button, and that's going to pop up the window, and then we go ahead and click on the little floating action button that has a cloud, which indicates downloading. And so what's going to happen now is this is going to go ahead and start communicating with the server, and you can see that there's a bunch of requests that are being made. You can see the server handling some of the requests over here, and there's also things happening over here in the various microservices as the communication's taking place. The real interesting part, of course, visually is happening here in the client app on Android. So you can see that it's downloading the images from the server, from a web server, and then it's going ahead and sending the images over to the microservices running the Spring Web MVC server, and it's applying the image transforms. You can see that each image is transformed to be grayscale or tint or sepia and so on. And then those images are sent back to the client where they're then displayed. So you can see the images are displayed here. So where we started out before with a certain number of images, we then basically transformed them and then returned them back to the client where they're actually displayed. And so this gives you an indication of how many images were involved, how many threads were involved, the amount of time that was elapsed. And that, of course, is a parallel processing operation. So the client is doing parallel processing for downloading, and the server is doing parallel processing on the image transforms, and then that information is being sent back to the client where it's being displayed, again using Java streams and parallel streams and Android and all kinds of other good mechanisms based on Java and Kotlin. So hopefully that gives you an idea of how to use the app and how to test it in its all full-blown glory of client-server interactions using Spring Web MVC and Java Parallel Streams.